Assalamu alaikum warahmatullahi wabarakatuh everyone. Hello and welcome back. Today we're gonna discuss the derivative sum rule. It's kind of fun. So the rule states that if u and v are differentiable functions of x, so the very same variable, then their sum, surprise, which is u plus v. This is not the surprise. The surprise is that their sum is also differentiable, and this derivative, the derivative of u plus v with respect to x, is equal to the derivative of u with respect to x plus the derivative of v with respect to x. So you're gonna distribute basically the derivative with respect to x to u, and then add to this the derivative with respect to v. So I hope with some examples everything gets clear. So our first example we have is the polynomial of y is equal to x to the power of 3 plus 4 over 3 x squared minus 5x plus 1. I'm gonna go over this in kind of detail to some extent, and then for our next example I'm gonna do it kind of, more casually. So here we can see that we have 4 functions. So the function we want to differentiate is basically the sum of 4 functions. So the first function we have is x to the power of 3. The second function we have is 4 over 3 times x squared. The third function we have is minus 5x. And the last but not least, of course, this is one, it's, plays a very substantial role in mathematics. So u4 is equal to 1, which is basically the same thing as 1 times x to the power of 0. So they follow the rule that all of them are functions of x. So we're good. So we're gonna differentiate each of them and then sum the derivatives we get, and we're done. So the derivative of u1 with respect to x is 3x squared. The derivative of u2 with respect to x is 4 over 3 is a constant, and then we multiply by the derivative of x squared, which is 2 to the power of x1, which is 8x over 3. And then the derivative of u3 with respect to x is basically, the constant is -5, so it's -5 times the derivative of x is of course just 1, because it's 1 and we subtract 1 from the power, which is already 1, so it's 0, and anything that's like raised to the power of 0, it's 1. So the short answer is just -5. The very last one we have here, the derivative of u4 with respect to x, is basically 1 is a constant, so the derivative of a constant is, as we know, 0, because a constant never changes and differentiation is all about changing. So the derivative of y with respect to x, as the rule tells us here, is the sum of the derivative of individual functions. So what we're gonna do is just we're gonna add all of these derivatives, each of which is a derivative of one of the individual functions we have here. So this is equal to 3x squared plus 8x over 3 plus minus 5 plus 0. So this is basically is 3x squared plus 8 over 3x minus 5. And that's it. Okay, let's try our second example. So our second example is y, which is our polynomial, is equal to x to the power of 4 minus 2x squared plus 2. So it's again the sum of individual functions. So the derivative of y is the sum of the derivative of each of this function. So dy dx is the derivative of the first function is 4x to the power of 3. The derivative of the second one is minus 4x, and the derivative of the last one, which is a constant, is just a 0. So the final answer is 4x to the power of 3 minus 4x. And that's it. Thank you so much, and I'll see you in our next video.